Welcome back to the ICE and D1 video series, and in this video we'll be talking about the different types of network, local area networks, wide area networks, and what they are and how they work. So let's start off with local area networks. So local area networks are made up of devices that live in the same area and are connected to the same network. And these devices are able to share information and share local resources. So the most basic example of a local area network is your home network, so your small office, home office network. So imagine that this is your house, and in every house we connect our PCs and laptops and phones to some sort of centralized device, which allows the devices to connect to the network and share resources. So this is an example of a basic local area network. It's a very small network. So we can connect our PS4 to it, or Xboxes, or maybe we got PC, we got laptop, we got like some sort of media server. Nevertheless, these devices all reside in the same local area. They all connect to the same network, so they're all part of the same LAN. These devices are now able to communicate and share resources and share information. So they're able to share files, they're able to send emails, send instant messaging. Messages and stuff, so they're able to communicate with each other. And local area networks, you can span a single house, a single floor, or even multiple buildings. So in this case, maybe we rent out a office space in a building, and we get the 5th floor. Now we create our own local area network, and all devices in the 5th floor are part of that LAN and are able to communicate and share resources. But the devices in the 5th floor, they're not able to communicate with devices in the 4th floor or share information or share resources, because devices on the 4th floor reside in a different local area network. To be able to communicate, so for devices in the 5th floor to be able to communicate and share information and resources with devices in the 4th floor, they'd have to go through some sort of device, what's called a layer 3 device, which connects the different networks together. So these two are seen as two separate LANs, and if we had another floor, that'd be seen as a separate LAN. A local area network could even span a whole building. So maybe we own this building, and all devices in this building connect to the same network. These devices would be part of the same LAN, and would be able to share information and share local resources. So in this case, let's say we had a printer on the 2nd floor, or the 3rd floor rather, and so from the 5th floor we'd be able to send down files to the printer on the 2nd floor and actually print out files, print out images and documents and text, all that kind of stuff. Or a local area network is not even confined or limited to a single building. It could even be a series of buildings which are close to each other, and devices in these buildings would be part of the same local area network. So maybe these buildings are in different streets, but those streets are within the same local neighborhood or the same local area. And so devices in, let's say, building 1, 2 and 3 would all be able to communicate with each other and share information and access resources that reside at these different buildings. So maybe we have some sort of file server here. The devices in building 2 and 3 are able to access and maybe able to upload files and try to download files as well. And the way that we would do this is that we would actually have cable running between these buildings. This cable would run underneath the actual pavement, so underneath the road. And normally it would be fiber optic cabling, allowing us to have high bandwidth connectivity between these buildings, between these sites. Now, all bandwidth is just the speed at which we can send and receive data. So essentially, the higher the bandwidth, the faster we can send and receive data, allowing data to be transferred between these buildings super fast, so within milliseconds. Now let's talk about the devices that actually make up a local area network. So a local area network consists of PCs, laptops, printers and servers, all that kind of stuff. And all those devices connect to a centralized device known as a switch. So a switch allows devices to connect to the local area network, allows a central point of connection, and essentially any device that connects to a switch is able to communicate with another device that connects to that same switch or connects to that same network. So in this case, we have 3 devices connected to the switch. They're all able to communicate with each other and share information. Normally we would use some sort of wired cable to connect to the switch. This is known as a UTP Ethernet cable, known as unshielded twisted pair. And so what happened This part of the cable, which connects to the PC or your laptop, would go into the network interface card on that device, and then it plug into a RJ45 port on the switch. A switch has got many RJ45 ports, many connections, allowing many devices to connect to it and therefore connect to the network as well. Now, with local area networks, we're not even limited to a wired connection. We could have devices even connect wirelessly to our local area network, making those devices portable, meaning that meaning that we could use one port to connect multiple devices to our network. Now, out this port would be what's called a wireless access point. Now, with a wireless access point, it broadcasts some sort of radio frequency, and when a device picks up that radio frequency, it's able to communicate with the wireless access point and share and send data in radio waves wirelessly without even having any connections, any sort of physical connection as a wire. We could even connect printers to our local area network, allowing us to send stuff to the printer so we could print out physical copies of, let's say, letters, images, documents. And every local area network also has at least one router. A router is a layer 3 device, allowing us to escape from our network and access somebody else's network, whether that be the internet, another enterprise site. So you can think of the router as probably the most important part of our local area network. Like, we could just have a local area network with PCs and laptops and a switch, but without a router, we're only confined to a local communication. We're only able to communicate with devices locally. We aren't able to access the internet or access another network and communicate with devices halfway across the world. It's the router which allows us to do that. And we'll talk about how it allows us to do that in a few more slides. So, with a local area network, like I said before, it allows devices in the same local area, whether that be the same house, the same building, the same floor, or a bunch of buildings which are in a close area to each other in the same neighborhood. It allows devices in those lands to be able to communicate with each other, share information, and share resources, and access different resources as well, like file sharing resources, automatic IP addressing, web server resources. Now, with LAN, Ethernet is the most commonly used LAN protocol in the world. There used to be multiple LAN protocols which existed, and all a LAN protocol is, you can think of it as a set of rules which define the type of cabling we can use in a local area network, but most importantly, defines how devices in a local area network are able to communicate and share resources. So from the previous slide, we know that we have all the physical infrastructure, all the physical connections to connect our devices together, enabled to share resources. But how do we actually use that physical infrastructure? How do we use all that physical cabling, or the wireless connectivity? How do we use it to so that two devices can actually communicate with each other and share resources? Ethernet is a set of rules that define when device A and device B want to communicate. As long as they follow these rules, they'll be able to communicate successfully with each other without any issues or without any problems. Some other type of LAN protocols were Tokering and FIDI, and those aren't used anymore. Ethernet was essentially better than all of those LAN protocols, and is the LAN protocol that we currently use for local area networks. And so with a local area network, the most important thing to remember, and the most important aspect which separates a local area network to a wide area network, is that with a local area network, we own the devices in a local area network. So we own all the PCs, we own all the printers, all the laptops, we own all the switches, we own all the routers, and because we own them, it's up to us to make sure that they're working. It's up to us to do any config or to configure any features on the devices that our clients and that our employees need. And it's up to us to ensure that they're working smoothly and the devices in a local area network have connectivity with each other. So let's move into wide area networks, WANs. So all a wide area network is, it's a network which connects multiple LANs together, allowing devices in those LANs to be able to communicate with each other. Now, the most popular WAN used is the internet. So the internet is the most popular WAN, and if you think about what the internet does, the internet just allows us to access resources and devices and web servers that could be halfway across the world. could be in different countries. So let's talk about the internet for now. So this is let's say this is your home. So with the local area network, our devices in our house are all able to communicate with each other. But normally, we have some sort of connection to an ISP, which provides us, known as the Internet Service Provider, which provides us with a connection to the internet. And so we have multiple houses or multiple clients connecting to the ISP. In essence, because these all connect to the same ISP, devices in this home or this house or this company would be able to communicate with devices in this house or this home. And so anybody that connects to this ISP, they would be able to communicate with other networks as long as they connect to this ISP. Now with the internet, to make the internet work, there's multiple ISPs with different ISPs for different countries. So as an example, in the UK we use Sky, Virgin Media and BT as our main ISPs. The ISPs themselves would have connections between each other. They'd have WAN connections between each other, allowing clients or allowing networks from multiple different ISPs to be connected to each other and being able to communicate. So now, LANs that use ISP2 as their internet connection can communicate and have access to LANs which use ISP1 as internet connections. So devices that use ISP1 can communicate with devices in ISP2. ISPs all have connections between each other, which essentially makes everything connected together, which makes the internet what it is. Which means that devices that connect to the internet are all connected together and able to communicate and share resources. And WANs themselves span a large area. So that could be between two cities, between multiple countries. So we could have a network in one city and in another city. The networks could be connected together with a wide area network. Another example of where a wide area network could be used would be an enterprise network. So let's say that we have a massive business and we have sites all over the world. So we have one in London, one in New York, and one in Madrid. So the way it works is that we'd actually use a wide area network to connect our local networks together, our local enterprise sites. And by connecting them together, it means that devices or hosts in the London site can access resources and devices in the New York site and in the Madrid site as well, which allows us that no matter which site we're in around the world, we're still able to access resources at that site. So we're still able to access files or services or servers at the New York site, or even call or message people at the Madrid site, all within seconds. WANs continued. So with a wide area network, we don't actually own the WAN. So explain this in simple terms. So with a wide area network, we know that it connects our local area networks together. We don't own any of the devices in the wide area network. Instead, another company owns the devices and builds that wide area network. We just pay a monthly fee to be able to use that wide area network to connect our sites together or to connect to the internet. So as an example, if this was an ISP, we pay the ISP for a connection to the internet, and as long as we pay for that connection, we can access anything on the internet. We can access any web servers, any websites. We can access anything. And so it's the same thing when we have an enterprise site as well. With the enterprise site, when we want to connect all of our sites together, we don't build a network connecting these sites together. That would cost too much money and wouldn't be feasible or scalable, or it'd be a administrative overhead. Instead, we actually pay some other company to connect our sites together, and as long as our sites are connected together, we pay a monthly fee. And so the way it works is that multiple customers connect to a WAN, and it is up to the WAN, to the wide area network, to the company that owns the wide area network, the WAN network, it's up to them to keep customer data separate and to ensure that when I send data and I want that data to go to my New York site, that data only goes to my New York site and doesn't end up at another customer site or at a different site. It's up to the company that owns the WAN. And normally, companies like telcos or an SP would own a wide area network and would allow us to access and connect all of our devices together from different sites or from across the world together, as long as we pay a monthly fee. And now let's talk about some typical WAN connections that we normally see. So the most common WAN connection would be a leased line. All a leased line is a direct cable running from one network or one site to another site. Now, this is a dedicated line, normally owned by a telephone company known as a telco, and only two other sites can exist on either side of the line. And so these connections are normally very expensive because it's dedicated. It's very, very secure because in the case you have site 1 and site 2, so site 1 is on the other end and site 2 is on the other end. There could be no other sites or no other networks that connect or that have connectivity to this cable. So it's very secure. So you can imagine it as a single cable running from one building to another building, connecting the networks in those buildings together. Another example of a wide area network is frame relay. Frame relay is a shared network in which we can have multiple customers connecting to that same network, and it's up to the ISP to keep this customer network separate. This is less secure than a leased line, but it's also more cheaper. So when we're looking at wide area network connectivity, we have to look at costs compared to security and all sorts of other things. And normally wide area networks are made up of routers. Routers are layer 3 devices. They connect different networks together. So normally at the enterprise side we'd have a router and a router at the edge of the ISP side. But within the ISP would have their own local area network connecting all these sites together. And like I said before, the internet is the largest WAN. So in this video, we've talked about local area networks and wide area networks and what they are. Local area networks connect local devices together, allowing them to share and access local resources. Wide area networks are normally operated by a different company like a telco or an SP or an ISP, and they allow us to connect our local area networks together, allowing full reachability and full connectivity throughout the world. I hope this has been informative for you, and I would like to thank you for viewing.